Greetings and welcome, friends. Today we're going to talk about the last type of conic section for us, right? We talked about circles, ellipses, hyperbolas, and now we're talking about parabolas. And you may recall you've seen parabolas before, all right? We've found out in the past, that wasn't a very good colon there, bam, there we go. We knew that in the past we could have, if I have an equation y equals ax squared plus bx plus c, we knew that that equation somehow represented the equation of a parabola. You may have even seen vertex form, y equals a parentheses x minus h squared plus k. That was also the equation of a parabola. And you've done different work with them. You've graphed parabolas before where, right, we know, let's see, some of the lingo behind them. We knew that parabolas had, let's say this is my parabola. Parabolas are kind of a U shape. That's not a very perfect way to describe it because the letter U actually does get perfectly vertical at some point. Parabolas do not. They get steeper and steeper, faster and faster. And a couple things that we knew about parabolas. The language will still be the same here. We had a vertex, all right, which was a turning point, you could say, in the curve, right? It was either a minimum or a maximum for us. And it also changed not only direction, but you could see that it changes slope, all sorts of interesting stuff there. It also had an axis of symmetry. Right? And that was cool. And the actual equation of the parabola, this was something that I kind of thought was interesting, is generally if a equals 1, if I go up 1 over 1, up 3 over 1, up 5 over 1, where if my consecutive quote-unquote slopes, all right, 1, 3, 5, 7, 9, 11, the consecutive slopes were, the slopes were consecutive odd numbers. All right, was kind of the idea there, an interesting relationship. And if A was not that, then the slopes, quote unquote, super loosely used term there. Well, I guess technically these are slopes of secant lines, lines that happen to hit the parabola at 2 points. Would equal a times 1 over 1, a times 3 over 1, a times 5 over 1, and so forth, right? Where the 1, 3, 5 are consecutive odd numbers. All right, so that was kind of all sorts of cool information we've known about parabolas in the past. Let's see, so these are consecutive odd numbers. Odds. You also, guys, you knew how to find the equation of the vertex in this form. We actually used to kind of use lowercase a, b's, and c's. But the vertex you guys were able to find was, let's see, what was it? Negative b over 2a was the x-coordinate of the vertex. And then just plugging that into the function f of negative b over 2a would give you your corresponding y-coordinate. All right, so you used to be able to find that. We knew that the y-intercept back in the day was 0, c, right, where it was just the constant. And you guys knew all sorts of wonderful stuff, and it was great. We're going to look at parabolas today in an entirely different light. There will be some similar features, though. One of the things I want to point about our equations is notice that our equations have always had a single squared term. You may remember that in all of our other conics so far, right, circles, ellipses, hyperbolas, they've had an x squared and a y squared term. So parabolas are just going to have a single squared term. All right, so that's kind of all of our quick recall on parabolas. So let's now think about parabolas in this new way. All right, so let's talk about the definition of a parabola. Let's see, a parabola is the set of all points Now, you guys are probably thinking this sounds familiar. We've done this before with our other conic sections. And our other conic sections, the circle was the set of all points equidistant from the center, which kind of behaved like a focal point, right? The ellipse had 2 foci, the hyperbola had 2 foci. It turns out the parabola, all right, even according to our graph here, we had a vertex, but it turns out there actually is a focal point in a parabola as well. It's the set of all points in a given plane that are the same distance from a given point, the focus, right? So there's only one of those, and a given line, which will be called the directrix, which just sounds awesome. So this is a somewhat entirely different way to think about parabolas. So let me actually, let me get a nice little picture going here. Well, let's see. So here it says a parabola is a locus of all points in a plane equidistant from a fixed point, the focus, and a fixed line, the directrix. So here's a point, the focus, here's the directrix. How would you find the distance? Like if I was talking where my mouse cursor is right there, how would I describe the distance between that and the directrix? Where would you measure to? Yeah, you'd want to measure straight down to that line, right? You'd want the shortest distance to the line, right? So if I start, well, say I was looking at my focus, if I want the distance from here to the line, I'm not going to measure this way, right? I'm going to measure perpendicular to that line, okay? So that's kind of one idea. So let's see, let's show the parabola. And what this is showing is that this distance to this point, okay, is going to be the same as the distance from the focus to that point. They're actually doing some crazy construction of a parabola right here, but that's fine. So those 2 blue distances are the same. Let's see, does it let me grab that? No, it doesn't. That's too bad. But no matter where I land, those 2 blue distances are the same. Is there an animate button you guys saw? Yeah, here we go. So you can see the 2 blue distances are fixed. They're the same, and that's what we were saying. They were equidistant. So I've got a point and a line, and I'm drawing all points that are the same distance from that, right? So that's the idea. Now, deriving the general equation, they've got all sorts of interesting stuff. So they have these 2 values. Actually, that value r we'll refer to as the value p later on, lowercase p. But they've got the vertex, they've got a point, and they end up kind of working their equation and end up getting a form of a parabola. We're actually going to end up using a slightly different form than this one ourselves. But there are kind of 2 forms for a parabola. Just like we saw the last night on the homework, where when you guys were writing the equation of the asymptotes, there's kind of 2 different types of point slope form. Same idea here, just a little bit different. So that's the idea about the construction. So let me just get a blank sketch, and let me just graph plain old y equals x squared. All right, and I'm just gonna start with this. Let's see. That's fine. That's fine. And I'll just hide these guys. Hide them. Let's see. Let's do this. Bam. Just so I can label some of the stuff going on here. So we still have some of the same information. We still have a vertex, okay, which is going to be our h comma k. And we're going to have this thing called the directrix, which this is definitely not going to be to scale. Let's see, what would that end up being on this graph? Now that I think about it, what would the value of p have been? 1/4 p. Well, I'm just going to draw it. I think it would probably end up being at 1/4, unfortunately. So I've got this line called the directrix, which is not part of the graph. It's used to create the graph. And then I've got inside, I'll draw that in a different color, I've got a single focus. All right? And we'll have this little value p. That doesn't show up at all. So the value p is either the distance from the directrix to the vertex. It's also could be described as the distance from the focus to the vertex, or it could be half the distance from directrix to focus. All right, so the value p is actually just some tiny distance here. All right. I suppose if I chose a wider parabola, I could have actually had a cooler looking sketch. But that's the idea, right? And now I'm going to talk about what these equations would look like. And it turns out, back in our recall mode, we only ever had vertically oriented parabolas, because we were always talking about functions, right, where for every input there was exactly one output. They had to pass the vertical line test. In this case, with conic sections, many of our conic sections didn't at any point behave as functions, other than, let's see if I get this right, the only conic section that was a function so far was the rectangular hyperbola, where that one technically could have passed the vertical line test. But it turns out we'll actually also be able to have sideways parabolas. Okay, so let's talk about some of the features of the equations, what standard form is going to be. Let's see, let me get a nicer green here. Bam. So standard form of a parabola. So let's first talk about our upright parabola. So we'll have x minus h all squared equals 4p times y minus k in parentheses. Is going to be our standard upright parabola. So let's see, our facts about this one would be that it's vertically oriented. All right. The vertex is going to be the point. What's your guess on the vertex? H comma k. Isn't that wonderful? Right? Because a parabola, unlike our other conics, doesn't have a center. But fortunately, everything can be viewed from the perspective of the vertex, which is really nice. The focus, I'm going to add the value of p to my k coordinate. And the focus, there's only one, so that's why it's just adding it. All right. The axis of symmetry, right, which we did have back in the day, right? It was just the line that the parabola could be mirrored over. It always passed through the vertex. That exists here too. Thing about the axis of symmetry that I'd want to point out is that We'll add it right here. Axis of symmetry. It is perpendicular to the directrix. It passes through the focus, passes through the vertex, right? Right, so there's our axis of symmetry. So the equation of the axis of symmetry is going to be the equation of a line. It's either going to be an x equal a number or y equals a number. Because this is a vertically oriented parabola, it's going to be y equals a number. Oh, I guess I'll switch back to yellow here. And y equals what number should that be? Well, it's going to pass through the x coordinate of our focus and vertex. So it'll be y equals h. Or, wait a minute, I just lied. Whoa. Y is not a vertical line. Guys, my bad. Shame on me. X equals h. X equals a number is a vertical line. My bad. My apologies, friends. Let's see, the directrix, all right, is the equation of a line. That's going to be a horizontal line, so that'll be y equals a number. How far is the directrix from the vertex? Yeah, it's p units away, right? So the directrix is a horizontal line in this case, and it is going to be passing through the point k minus p. All right, so it's p units underneath the y coordinate of the vertex, right? So k minus p would be p units down from it, right? So there's our directrix. And then there's also this concept of which way it opens. And it opens up if p is positive. All right, we used to have that before as well. And it opens down if p is negative. Right, so a little graph of what this might look like. All right, I'm talking about this sort of parabola, right? It's vertically oriented. So it could also open down, right? Something like that. So let's talk about a horizontal parabola. Also, I want to point out, notice there's no A, B, or C that I'm worrying about because I don't have to find more than one vertex. I don't have co-vertices. I don't have all of that stuff. So there's no A squared, B squared, C squared thing either. So let's see. You'll see. Oh, that's what I want to point out. I also remember that this one's the vertical one because notice the square is related to the x. All right, that's how I know that this is a vertical one. And I know that because all of the parabolas I'd experienced up to this point, the square was related to the x. Okay? So anytime you see that, that's how you'll know that it's a vertically oriented parabola. So for a horizontally oriented one, it'll be y minus k squared, right? So now the square is related to the y equals 4p times x minus h. And you guys can probably guess most of our facts here. So let's see, our vertex is going to be at h comma k still, except notice that h, right, is always associated with the x, the k is always associated with the y. Our focus, oh actually, wait, I forgot, this is horizontal. I forgot to mention that. Horizontally oriented. Well, that's not what I meant to do. I meant to draw like a cool horizontal line here, just separating these two concepts. There we go. There we go. So, focus is going to be p units away from the vertex, but in the horizontal direction. So that's going to be h plus p comma k. Right? The axis of symmetry, which sometimes I'll abbreviate as AOS. This time is a vertical line, so it's y equals a number. And which point do you think it passes through on the vertex? The x or the y coordinate? K, yeah. It's going to be the opposite of this one up here, right? And let's see, then what do we got? We've got the directrix will be x equals a number. And how far away from the from the vertex is the directrix? P units away, except instead of h plus p, it's going to be h minus p. And then this one, I can figure out which way it opens. This one opens to the right, right? Because it's horizontal, so it's going to be a right or left comparison. It opens to the right if P is, what sign do you think P would have to be? Positive or negative? Positive, right? Because in the right direction on our x-axis, that is the positive x-axis. So for P greater than 0, it opens to the right. It opens to the left for P is less than 0. Good stuff. So I guess I'll draw a quick little picture just to let all our friends know. That's not a very straight line. That's a little better. So this parabola would look like this. Ugh, man, I'm terrible at drawing sideways parabolas. Right, something like that. And our directrix would be vertical. Our focus would be somewhere there. Our vertex. We've got an axis of symmetry. All sorts of great stuff going on, right? Good times, good times. So let's actually do some problems here then. So yeah, I think you can see that this is kind of very unique compared to the other conic sections. Its equation doesn't relate to the other ones as much. So let's see. Let's find all info and graph for the following. What if I've got y squared equals 8x plus 48? All right. Now, looking at this is not currently in my standard form. So, do you suspect that this is a horizontal or a vertical parabola?
Horizontal.
And what made you think that? Because the y is squared. Perfect. All right, that's exactly what I want you to think. So I want this to look like this. Right? So I'm going to try to get it to look like that. So on the x side, it looks like I need to have x times something. And notice the leading coefficient here is always 1 on the x. So I'm going to factor that 8 out of it. And also for the y, I'm just going to be super redundant and unnecessary. And I'm going to rewrite that as y minus 0 squared. Right? And then for the x, I'll have 8 times, what? 8 times what is 8x? X, yep, plus 6. Okay, so this is now kind of much more in my standard form that I'm used to, right? So it's not nearly as crazy. So let's see what information I can gather. Okay, what is the vertex?
6.
Nope.
Negative 6.
Positive 0. I love it. Yes. I love it. And we already said that this was horizontal. I guess I can specify that. Right? Let's see. What else do I know? I need to find out what the value of P is. Now, I know that 4P is going to equal this number here. Okay. So 4P equals 8. So to solve for P, I'd divide both sides by 4. And I'd end up with P equals 2. Okay? So that means my focus, now let's see, P is positive, so which way does this open? Right. Right, because it's horizontal. Okay, so my focus I'm going to add 2 to which coordinate? Right, so -6 plus 2. Normally I wouldn't have to write that out, but just for the sake of our notes, our first example, it's not a bad idea to. So there's our focus. Let's see, what was I hidden first? Usually axis of symmetry. I guess I'll keep the same pattern. So the axis of symmetry is also going to be horizontal. So that's going to be y equals, and it'll equal the y coordinate of the vertex, so y equals 0. And the directrix is going to be x equals what, do you think? Yep, is right. It's the, in this case, it's the x coordinate of the vertex subtracting p. So that's x equals -8. And just for the axis of symmetry and the directrix, some people want to just say, oh, 0 and -8. But that's not, they're not numbers, they're equations, all right? So y equals 0 is the equation of a line. All right, x equals -8 is the equation of a line. So I just want to make sure you don't just like say, oh, it's -8. Like that's not what it's actually saying. Let's see. So we got the directrix. We know which way it opens. I think we've got everything here pretty good. Let's see if I can get a nice little grid for us going here. I'll delete this guy. Let's see. So let me visualize what quadrant I'm going to be in before I start drawing this. The vertex is at -6, 0, so that's to the left, and then it opens right. Okay, so I need to just make sure that it goes at least to -6. I know it's going to be symmetric, so top and bottom. I think I'll hit the same amount in both of those cases. Oh, and actually, and the directrix is x equals -8, so I actually have to go all the way over to -8, don't I? All right, so let's see. Hopefully this is enough room for us. That'll do. So let's start plotting the information we know. So the vertex is at -6, 0. So here's my vertex, right? The focus is 2 points to the right of that. All right, so there's my focus. The directrix, I already forget what color I was using for that. I don't know, I guess I'll use this purple or something. No, what color did I use? I might as well be consistent. I used orange. Okay, all right. Not your best choice, Mr. Waddy, but that's fine. Let's see. So that's a vertical line right here is my directrix. And now let's start plotting some. Oh, and then I can also plot the axis of symmetry if I want it, right? Which is going to be passing through those. So it's mirrored over that line, right? So let's see if I can start plotting some points. So here's my vertex, right, at -6, 0. And notice that it is 2 units away from the directrix, and that is 2 units away from the focus. So now, like, for the, like, say, like, is this the next right point? Is that the same distance as that? No, that's not quite right. It kind of, like, it'd be a pain to try to guess those. So I usually have one that I'll start with. I look at the whole distance across from the directrix to the focus, which is 4, and I'm going to go up this far, 4 units, and 4 units that way. So I kind of find my 2 perpendicular points, I guess, because notice that this point is 4 units away from there, and it's 4 units away from the vertex, or sorry, the focus, right? So I do actually accomplish my 4, 4. So that point is the easy one to grab. And then I think because you guys have seen so many parabolas before, usually I used to require 5 points to draw a parabola, but I think I'll let you get away with just these 3. So it's something like that, and it's mirrored. And let's see, I might, let me, do I have another good color here? Yeah, so this is 4 and 4. Which I guess technically those were, if you want to have a way to do that, it's 2p. I don't know, right? Because p is this distance here, right? This was p, this was -p, right? Or whatever. So yeah, I just found the distance the whole way across from directrix to focus, and then I went that far in both of those directions. And I find like those are the easiest points to graph. Now technically, this is actually maybe a tough question. I haven't even thought it all out myself. Now, back in the day, we technically had the consecutive slopes going on, but I don't know what the value of this A is to know what those slopes are in this case. I'd actually have to kind of rearrange this. Right? Because in that case, the A was whatever was in front of the squared parentheses. So I'd actually have to like modify this. I'd have to divide both sides by 8 in order to understand that slopes technique, which this is I guess, I'm just going to call this a consider. All right, this is not something you'll actually do tonight, but I just want to try to bridge a gap between our two concepts of parabolas there. So let's see, what was the equation? It was y minus 0 squared equals 8 parentheses x minus 6 plus 6, right? Was that what it was? Okay, so let me write this in vertex form, which by the way, actually let me label those. That's not a bad idea. This was standard form. Well, I'm not going to have a name for that because standard forms, I don't want to confuse you guys. This one was called vertex form. I'll at least commit to that. Was what that was called. So let's put this over into vertex form so we can find out what this A would have been referring to. So to do that, I'll divide both sides by 8, or multiply both sides by 1/8 maybe is the, I don't know which way is easier for you to perceive it. So I'll have, and I'm going to flip it, x plus 6 equals 1/8 y minus 0 squared. And then I could subtract 6 from both sides. So I get x equals 1/8 y minus 0 squared minus 6. So here's now vertex form. All right. And that means that the value of A was equal to 1/8. So my slopes, and what's really weird is you're not allowed to reduce these, would have been 1/8 times 1 over 1. All right, which actually I'll do these kind of vertically this time. 1/8 times 3 over 1 and 1/8 times 5 over 1, which simplify to 1/8 over 1, 3/8 over 1, and 5/8 over 1. So this is all stuff, you don't have to do this tonight. I'm just trying to relate these to make sure we'd actually have the same graph. So I would have said the vertex was still 0 and -6, although in a horizontal perspective. So let's see, 1/8, 3/8, 5/8. So from my vertex, let's see, here's -6, here's -5. I would go over 1/8. Okay, so let's see, here's a half, there's a quarter, there's an eighth. 1/8 is very tiny. Over 1/8 up 1 would have landed me there. From there I would have gone over 3/8. So 1/8 plus 3/8 is 4/8, which would have landed me at my halfway mark, and up 1. Okay, so over 1/8, over 3/8, and then over 5/8 from there would actually land me at 1 1/8 and up 1. And it does appear as though I'm actually hitting those points. So not necessary at all. You're allowed to just do the little P trick here, right? So you just find those 3 points. But I just want to point out that we actually would have ended up with the same parabola both times, which isn't that bad. Not that bad at all. Let's see. I've got 5 minutes left. How long has this video been going? I feel like it's been a while. 34-minute video. We've got one example done. For sake of just analysis, well, actually, let's talk about general form real quick. and maybe we'll do one problem. So let's see, general form is either y squared plus dx plus ey plus f equals 0, or it will be x squared plus, that's a d, not a 0 there, by the way. It's a sad looking d. Dx plus ey plus f equals 0. So this is general form for parabola, right? The top one would be our horizontal, and the bottom would be our vertical, based on the which term is squared, right? So let's do an example where I have something in general form and I put it in standard. We won't graph this one though. So let's say write in standard form. I guess period there, fine. So let's say I've got 2x squared minus 8x plus y plus 6 equals 0. So based on this, depending on which term I have squared, is going to determine how I break this up. All right, so is this horizontal or vertical? Vertical, because the x is squared. So what I'm trying to get this into is this form, x minus h squared equals 4p times y minus k. That's what I want to get it into. So notice in this form, my x's are all on the left, my y's are all on the right. Okay? So let's do something like that. I'm going to rewrite this as 2x squared minus 8x equals, and I'll have negative y minus 6. And in order to get something like this, we've always had to complete the square, because that's the square of a binomial. So let's go down the complete the square route for these x's. So I'll steal a 2 out of both of those. So 2 times x squared minus 4x blank equals negative y minus 6 blank. Yeah, class is just about over, guys. So you can start packing up and leaving, but I'm going to keep recording this, so have a great weekend. Let's see, complete the square. I'll have negative 4 over 2 squared. Negative 2 squared equals 4. So add 4 here, which is really adding 8, so I'd have to add 8 over here as well. Right? So I'll have fast factor, the 2 still out front, x minus 2 all squared equals negative y plus 2. Okay? And let's see, comparing this to the standard form I'm shooting for, this 2 won't be here. So I'm going to divide everybody by it. Yeah, so you guys can definitely leave. I'll just post this online. I think you can see where the rest of this is going. Thanks for hanging out, though, friends. X minus 2 all squared equals negative 1/2 y plus 1. And now I've almost got it there, except I need a positive 1 coefficient for the y in that set of parentheses. So my last step, I'm actually going to factor out a negative 1/2 from both of those. So I'll have x minus 2 all squared equals negative 1/2 parentheses y, and negative 1/2 times what is positive 1? That would be negative 2. And now this is in standard form. And we can see that the vertex would be 2, 2. The value of p is actually a little bit tricky to find. So I would have, remember that 4p is equal to that negative 1/2. So I'd actually have to multiply both sides, or sorry, divide both sides by 4. I'll get p is equal to 1/8 in this case. Let's see. Sorry, negative 1/8 by the time I'm all done. So, so there you go. That's how you could convert from general form to standard form. Thanks for hanging out, friends. Apologize for the long video, but we did cover a lot. Have a great day. Bye-bye.